sikit on the substructure analysis, right? So we have column design, right? So apa ni? This is one example lah. Okay, when we have the pin jointed connection, okay, between the beam and also the column in a precast concrete structure, right? So the four-story brace column, as shown in the figure, carries beams on either side in a symmetrical arrangement, right? Okay, so dia ada this is an internal column, right? So kalau kita tengok daripada this figure, so it is an internal column. So bila kita sebut internal means that it has the beams okay, connected to our column okay, on both sides, right? So kiri kanan dia adalah. Right, so basically, usually for this substructure analysis, okay, we are going to do the analysis in 2D, right? So maksudnya 2D kita consider per axis lah, right? So yang ni kita tengok daripada depan sahaja, right? So we are going to have the beam okay, on both sides, right? So kiri dan juga kanan. Then bila kita buat analysis in the other direction, okay, another axis, then kita akan tengok in the other direction lah. Then most probably we are going to have another two beams okay, that is connected to the same column, right? Okay, so the distance from the face of the column okay, to the point load V is nominally 60 mm. Right, okay, so yang ni adalah dia punya distance of this V, right? So V ni adalah dia punya shear force, right? Okay, so when we have the beam, okay, so if you see from this figure, right? So this is the figure where we have the beam, okay, that is put into the support of the column, right? Okay, so kita ada V, so V ni adalah dia punya load lah, okay, which comes from the beam. So if we calculate, okay, so actually this load, okay, will come from the reactions. Right, so bila kita calculate tu, then kita akan dapatlah dia punya reaction. So kalau katalah we have a simply supported beam, right, okay, so katalah UDL dekat atas dia, W, right, so the reactions, okay, or the V value is this one. Right, so dekat hujung, okay, so ini adalah the V that we are going to consider okay, at this location, right? So dekat hujung ni. Okay, so this is the V value, right? So dia punya reaction, okay, that is acting on the column. Okay, right. So apa ni? The construction allowance, okay, is 10 millimeters, right? So where the beam and reactions are given in table 4.13. Right, okay, so dia punya values okay, of the loadings okay, are given in this table, right? So dia dah bagi dah dekat sini, okay, the loads from the roof, okay, and also the loads from the floors, right? Okay, so we know that in the design, okay, the loads that comes from the roof will be different from the floors, right? So selalu dekat floor akan ada lebih besar lah dia punya loading sikit in comparison to roof. Right. Okay, so we have the permanent action and also we have the variable action. Right. So kalau tengok value dia adalah a bit different. Okay. So the construction allowance is 10 millimeters. Okay. The beam and reactions okay, are given. So for the purpose of this exercise, use the ultimate load combination factor of 1. Right, okay, so let the effective creep factor okay, of equals to 1, right? So yang ni dia consider juga dia punya effective creep factor, right? So given the concrete grade C40, right, with the steel of 50 Newton per millimeter squared and cover of 35 K to 10 millimeter diameter lengths, right? So yang ni untuk design lah, right? So yang tu kita tak pakai. So what I'm going to show you here is just on the analysis of the column, right? So calculate the maximum and minimum axial loads and moments. Okay, then draw the bending moment and axial force diagram. Right. Okay, so you can see here that this is our column, right? And it is connected to beams on both sides. Okay, and it is using the pin jointed connection, right? So pin. So bila pin biasanya kita akan letak bulat lah, right? So it means that we are not going to have any moments at that joint, right? Okay, and also given here, okay, in figure 4.51, okay, we are given the height of the floors, right? Okay, so kita ada 3.6 meters, okay, from the foundation, okay, to the ground floor. Okay, then we have from the ground floor to the first floor is 3 meters, right? So yang lain ni semua adalah 3 meters respectively, okay, up to the roof floor, right? So yang atas ni adalah roof floor lah. Okay, so this is the most top. Oh, dah tulis dah kat situ roof. Okay, right. So here, okay, we are going to look into the loadings, okay, transferred to the apa ni, column, right? Okay, so what I'm showing you here is an internal column. So bila dia internal, then kita akan ada beam from both sides. However, if it is an external column, right? So this is an example. Okay, kalau kita ada column kita yang external, okay, so therefore it will be, the beam might be from only one direction. Okay, kalau kata dia dekat hujung, okay, for example, katalah kita punya building tu macam ni. Allah. Okay, right, so column awak duduk dekat hujung ni. Right, so this is another column. Okay, right, so let's say this is another one. Okay, so yang ni adalah internal lah. Right, so kata dia duduk tengah-tengah ni. So this is internal. Okay, tapi if we look into this column yang dekat hujung ni, right, okay, so we only have the beam, okay, only on two sides, right? So kita ada satu dekat sini, another one dekat sini. So kalau kita tengok daripada one side, okay, so therefore the beam, okay, will only be from one direction. Okay, so sebelah sahajalah, so kita tak ada dua-dua. Okay, in comparison to what we have, okay, in our example. So kalau kita punya example tu, okay, katalah this is the column that we are considering, right? So therefore the loads will come from both sides, right? So akan ada dua arah. Okay, right. So you need to know this. Okay, so in view of the design, okay, then you need to know the location of your column, right? So these are the loads. So try 300 times 300 millimeters column. Okay, this being the smallest recommended size for a 4-story building, right? So assume 20 millimeters bar, right? So therefore D is equals to 245. Okay, so the first thing that we have to calculate is the self weight of the column, right? Okay, so kita calculate self weight, right? So 0.3 times 0.3, which is the cross sectional area. Okay, then multiply with 25. So 25 is the density of reinforced concrete, right? Okay, so multiply with the total height of the column. So total height of the column ni, dia punya total ni lah, right? So we can total this up. Right, so kita dapat dekat sini 12.6 meters. Right, so ini yang kita multiply dengan 12.6. So we have here 28.4 kilonewton. Okay, then the maximum axial load per floor, okay, we can calculate using the ultimate limit state. Right, okay, because we wanted to design, okay, the RC structure. So the RC structure lah, dia is no longer pre-stressed. So we are going to start with ULS. Right, so the FOS, okay, or partial factor of safety that we are going to use for these loads, okay, are 1.35 and also 1.5, right? So we are back to the macam kita punya RC design. So calculate here, right? We are going to calculate the NED max, right? So NED max, so kita ada dua tadi, right? Okay, so we have the self weight of the column. So self weight of the column is also considered as a permanent action, right? Okay, then yang ni adalah self weight 28.4. Okay, then multiply with the loads that comes from the from the roof, right? So loads that comes from the roof is 80. Right, okay, then kita ada tadi, kita kata the beam comes from both sides, right? So therefore 80 multiply with 2, right? Okay, so ini yang kita ada 80 multiply with 2, then plus with, okay, 108. So these are the permanent action that comes from the other floors. So tengok pula other floors ada berapa floor, right? So kita ada 1, okay, 2, 1, 2, and also 3 floors, right? Okay, so all the loads has to be accumulated, right? Okay, so from each floor, okay, we have the loadings of 108. So 3 times with 108 times with 2, right? So dia kena kali 2 lah, okay, because we have 2 beams on both sides, right? So that is the permanent action. So similar method, okay, is used for the variable action. So kita ada variable action for the roof is 27, okay, and variable action for the floor is 90, right? So masukkan pula dekat sini, multiply with 1.35 and 1.5, right? Okay, so therefore we are going to have here 2020, okay, 0.1 kilo Newton, right? Okay, so yang tu dia punya total NED, right? So dia punya total axial load. So the total NED minimum, right, we are going to calculate both. Okay, tadi satu tu kita calculate for maximum considering ULS. Another one is considering SLS. Okay, because we wanted to have the difference between the value of moments, right? Okay, so now we are going to multiply, okay, the partial factor of safety of 1, okay, multiply only with the permanent action. Okay, dengan permanent action sahaja, right? So kita tak masukkan the value of variable action. So therefore we have here 836.4 kilo Newton. Okay, right. So next one, okay, we are going to calculate for the maximum bending moment, okay, that occurs owing to patch loading alternating on successive floors, where the beam action V, okay, minimum on one beam and V maximum on the other beam. Right. So bila kita nak calculate dia punya moment transfer, okay, so therefore we are going to consider, okay, maximum and minimum, right? So alternately lah, right? So pasal kita nak dapatkan value dia yang paling besar, right? So the eccentricity of V at each side of the column about the center line of the column is considered as E equals to 0.5 H plus with 60. Okay, then plus minus with the construction allowance of 10 millimeters, right? So bila dia kata dekat sini dia ada plus minus dia, so plus minus dia adalah 10 millimeters. So when we calculate this, right? So calculation dia saya tunjuk dekat atas ni. So E is equals to 0.5 times with H. So H ni adalah H of columns, right? So columns H, right? Okay, which is 300. Then plus with 60. Yang ni memang dia punya equation, right? So we can just follow. Right, so here we have 0.5 times 300 plus with 60, so we have 210 plus minus with 10. Right, so ini adalah punya construction allowance. Then bila dia kata plus minus, so therefore kalau minus then kita dapat 200. Okay, then kalau kita plus then we are going to have 220 maximum. Right, okay, so kita ada dia punya construction allowances, okay, that we have to consider. Right. Okay, so the next one is that we have to calculate for the maximum moment, right? Okay, so tadi kita dah calculate, right? Okay, so we have the values of the permanent loadings, okay, and the permanent loadings, the maximum loads, okay, and also the minimum loadings, right? Okay, so kita akan masukkan di dalam equation, right? Okay, so maximum moment yang dia calculate dekat sini adalah maximum moment. So E will be 0.22, right? So in order to calculate the value of moment, dia kena ada lever arm, right? So tengok balik this figure dekat atas ni, right? So kenapa kita multiply dengan E, right? So kita ada V, right, which is the load, and also we have E, right? Okay, so this E is the eccentricity, and this eccentricity is considered as the moment lever arm. Okay, ni nak cari dia punya moment. Tadi kita dah cari dia punya NED, which is the loads. Okay, so multiply with the distance, right? So itu yang kita multiply dengan 0.22. Okay, meters, right? So tadi dapat 220, so in meters it's 0.22, right? So then multiply with 1.35 permanent plus with 1.5 variable minus with the minimum moment. Okay, so yang ni tadi adalah maximum moment. Ni maximum moment. Mana maximum. Okay, then yang ni pula adalah minimum, right? Okay, so multiply, okay, and you can see that the E value that we are using here also, this is E max and this is E minimum, right? Okay, so multiply, then kita akan dapat dia punya value at roof, okay, dia punya difference, okay, is 32.67 minus with 16, okay, so the difference is 16.67. while at floors, okay, the value is 61.78 minus with 21.6. Right, okay, so we have here 40.18 kilonewton meter. Right, so dah dapat dia punya maximum moment. Okay, then we are going to calculate the moment distribution factor. Right, okay, so untuk moment distribution factor ni, you can go back to your moment distribution method, right, because we are still using the same thing, okay, whereas we are calculating based on the distribution factor. Right, so nanti boleh balik lah, tengok balik dia punya calculation tu macam mana. Right, okay, so what we are calculating here is the value K. Right, so K is the stiffness factor. Okay, then the distribution factor, okay, kita akan bahagilah. Right, so for each floor, okay, we are going to have the top and also bottom distribution factor. Right, so kalau tengok dekat sini, then yang saya tulis kat sini yang biru ni adalah dia punya distribution, dia punya stiffness factor. Okay, then the distribution factor, okay, will be K divided by summation K. Right, so yang ni dia punya equation of the distribution factor. So kita pakai yang sama, right? Then we are going to calculate for the distribution factors, okay, which are the ones that I have highlighted here, right? So for each tu kita kena calculate, okay, and then we are going to get the distribution factors for the top and bottom of the column, right? So for each column tu kita akan ada the value, right? And then we can calculate the bending moment diagram, right? So for each bending moment diagram, okay, then moment tadi yang kita dapat, this one, okay, we have to multiply with the distribution factor, right? So kali dengan distribution factor, so you can see here, okay, that we are going to get the values, right? Okay, so for each two, top, bottom, semua kita akan dapat bila kita multiply dengan dia punya distribution factors. So this will be the bending moment diagram. Okay, then the next one pula yang sebelah kanan kita ni adalah dia punya axial force diagram. So daripada atas tu, so basically it will go top down. Right, so the top one will have lesser loadings in comparison to the cumulative loading at the bottom of the column, right? So dia akan add up lah, right? So yang ni dia ada correction sikit, okay, pasal yang ni saya ambil daripada buku, tapi when it is calculated then the values tu ada ada salah sikit, right? So you can see daripada belah tepi ni, right? Okay, so we start with 297 on top, right? So yang ni atas sekali, right? Okay, then they accumulated, okay, until it reaches 2020.1. Right, so you can see that for the axial force diagram, right, so it tends to increase, okay, as it goes down, right? So bila kita design foundation, okay, then we are going to take the value for the foundation at the bottom, right? So dia akan duduk di belah bawah sekali, right? Okay, so yang tu adalah dia punya maximum loading. Okay, alright, so any questions? Kena laju sikit pasal saya tak done. Okay. Boleh?
Boleh, madam.
Boleh?
Madam.
Alright. Okay, so nanti boleh try buat yang ni, right? So you can just simply try to calculate, right? So try to calculate, tengok macam mana nak dapat dia punya value of the distribution factors. Okay, alright. So kalau ada apa-apa nak tanya boleh just WhatsApp me, right? So don't forget to take your attendance. Saya pun ada kelas ni pukul 10 another class. Okay, right. So don't forget to take your attendance in the near future, right? So let's end our today's class, okay, with tasbih kifarah and surah Al-As. Alright. Okay, so thank you very much everyone. Right, so don't forget that you have to submit your mini project by this weekend. Okay, right. Oh, saya tak ni lagi dekat Teams. Nanti saya buat dia punya submission punya link. Okay, right. So thank you very much everyone. Assalamualaikum.
Thank you, madam.
Salam.
Thank you, madam.
Thank you, madam.
Alright.